So let's do it. The other part of lesson 4.9 is we're doing parallel lines. Give me a quick preview of what you know about parallel lines and their equations.
They have the same slope.
Parallel lines have to have the same slope. Okay? What else do we know? Is that the only important thing, Josh?
They have to have a different y-intercept.
They have to have a different y-intercept. Okay, is there anything else? Okay, so what if they do have the same slope and the same y-intercept?
It's the same.
It's the same line. They're both starting at the same place. They're both rising and running at the same rate. So they have to end up being the same line, don't they? Okay, here's where, once I introduce the other part of lesson 4.9, perpendicular lines, you have to keep parallelism separate from perpendicular, okay? So non-vertical lines are perpendicular if and only if the product of their slopes, what's product mean? Where something's being multiplied, that's right, so it is the answer for a multiplication problem. So if you multiply the slopes, you better get -1. So the slopes are not the same, because can you take a number times itself and get a -1? Can you? Can you think of a number that if you multiply it by itself, you'd get a -1?
No.
Anybody? I can't either. I don't think there is. Okay. Can you think of any numbers that if you do multiply them, you get a -1?
1 times -1.
1 times -1 would be -1, wouldn't it? Okay. Think of any others. There's an infinite number of them, so start showing them out.
4 times -4.
4 times -4, is that -1 class? What is that?
-6.
-16. So 4 times -4, that's not going to work, but I bet we could find something that has one of those numbers in it that would work. What could we multiply times 4 to get a -1?
Put a 1.
Feeling like I'm asking.
-1/4.
Oh, thank you, Brady. -1/4. Remember, when you multiply reciprocals, you get what? What's the product of reciprocals? 1. And when you take a positive times a negative, you get a negative. So 4 times -1/4 would be -1, wouldn't it? Okay, now I bet you can start giving me some. Braden's helped you out. 9 times -1/9. Andrew?
5 times -1.
5 times -1/5. Andrew?
6 times -1/6.
6 times -1/6. How about, what would we take times 1/3?
3.
-3. -3. Okay. So getting the picture of what the slopes are going to have to look like? The slopes of our lines are not going to be the same. They are going to have, if we multiply them together, they're going to have to create a -1. And then, since it talked about that's the case for non-vertical lines, what do you think would be the case for vertical lines? Vertical lines would be perpendicular to what? Well, maybe we should back up here a little bit and talk about perpendicular. What's perpendicular mean?
2 lines across.
The 2 lines across. Okay, so these lines are perpendicular right here that I'm forming with my arms?
Yeah.
They are, huh? No, they're not.
Oh, they form a 90-degree angle.
Oh, they have to form a 90-degree angle where they intersect. So not just any old pair of intersecting lines are perpendicular, but when 2 lines intersect, when they cross, and where they cross, they create 90-degree angles. Then we can say they are perpendicular. Okay, well then I want to know what would be perpendicular to a vertical line. A horizontal line, okay. So vertical lines are perpendicular to horizontal lines. So if you'd already filled in the blank and that was your answer, pat yourself on the back. Okay. Now notice, how are these different than parallel lines? Make a comparison for me, because you're going to have later on in the week, you're going to have a worksheet where you're going to have to work with both parallel and perpendicular, and you can't mix the 2 up. So make a comparison for me here between parallelism and perpendicularism, if that's the word, I think it probably is. Really? Yeah, you can't. Slopes of parallel lines have to be
The same.
the same. Slopes of perpendicular lines have to multiply to be -1. Okay? Y-intercept of parallel lines have to be different. Y-intercept of perpendicular lines? Did it say anything about that? Do you think it's possible that two lines could be perpendicular and they would actually cross at the y-intercept on the graph? Do you suppose that's possible? Could that point of intersection be a y-intercept? Absolutely it could, and then they would share the same y-intercept, wouldn't they? So perpendicular lines do not have to have different y-intercepts. They could care less about the other one's y-intercept, okay? So, and then the other thing we talk about is vertical lines are parallel to what kind of lines? Vertical lines are parallel to what kind of? Vertical lines. Vertical lines are perpendicular to what kind of lines? Horizontal, okay. So the product of a number and its reciprocal is, we already talked about this, the product of a number and its reciprocal is product of a number and its reciprocal, 1/3 times 3. 1, okay. Therefore, the product of a number and the opposite of its reciprocal. The product of a number and the opposite of its reciprocal would be -1 then. So in other words, when we have perpendicular lines, tell me something that you're always going to look for to see if it's even possible that they're perpendicular to each other. What would have to be true about their slopes?
One would have to be a fraction.
One would have to be a fraction. Well, not always, because aren't 1 and -1 reciprocal? Or opposite reciprocals?
Yes.
Yeah. So one doesn't have to be a fraction necessarily. But what? One has to be what?
The negative.
A negative, and the other has to be
Positive.
a positive. So you have to have a negative slope and a positive slope when you're talking about perpendicular lines. So I gave an example of what's happening here? What am I doing there? Multiplying what?
The reciprocal.
Reciprocals times each other. 1/4 times 4/1, also known as 4, gives us 1. What do we have to multiply 1/4 by to get -1? -4. And of course we can put it over 1, and then we would get +4 or -4 because we'll give the negative sign upstairs over +4, which would equal -1. So again, when we have perpendicular lines, we need them to be, the slopes to be reciprocals of each other, one of them to be positive, the other to be negative. Okay, so page 297 in your books, let's just open it up. Just in your homework again, you will do some problems like these, and what kind of work do you need to have to support it? Tell me what the directions say for numbers 5 and 6, please. Identify which lines are perpendicular. How many equations did they give you?
The first one has.
4. There are 4 of them in number 5. Aren't there 4 equations?
Yes.
Making for 4 lines. We want to know if any of those would be perpendicular to each other on a graph. So when we are looking for perpendicular, what we need to, do we have to worry about the y-intercept? No. What do we only care about?
Slope.
We only care about the slope. So what is, our first equation is given to us in slope-intercept form, so what's the slope?
2/3.
2/3. Our second equation is given to us in slope-intercept form, so what's its slope?
-2.
-3/2, -3/2, okay? Y equals -1. What's its slope? 0. What's the reciprocal of 0?
0.
What's the opposite of 0?
0.
0. So in other words, do we have, what's going on here? If we have y equals -1 with a slope of 0, what do we really have? A horizontal line. That's how we're going to identify it. Identifying slope for these does us no good. We're going to say this is a horizontal line. And I know that if I have a horizontal line, if I'm looking for a line perpendicular to it, it has to be what? Vertical. Okay, tell me what x equals 3 is. It's a vertical line. When the y's are missing, it's a vertical line. When the x's are missing, it's a horizontal line. Remember I told you to plant that. Okay, so we have a vertical line here. The y's are missing. Okay, do we have any perpendicular lines here?
Yeah.
Okay, which ones? Pardon? These first two are? Okay, so we're going to say that y equals 2/3 x minus 4. I'm going to guess you don't want to write that long word perpendicular, so is perpendicular to, that's the math symbol for it, is perpendicular to y equals -3/2. That's a messy equal sign. X plus 2. Okay. Any others?
3 and 4.
The last two are also, because one is horizontal, one is vertical, so we can also say that y equals -1 is perpendicular to x equals 3. We have two pair of perpendicular lines. Now, I want us to put into the graphing calculator. We cannot graph a vertical line in these graphing calculators. I'm going to guess the newer models can by now, but we can't in here. So we're going to just check out that first pair, okay? So would you go, turn it on and go to y equals, put out anything in there. Yes, Josh?
It says that my batteries are low.
Okay, then you need to turn that one off, put it up on my desk, we'll put new batteries in it, and you take a new one. I want the coverage here. Okay, how do we put in 2/3?
Parentheses.
Parentheses, 2 divided by 3, parentheses, don't put the x until you close the parentheses, and then put your x, and then we are to subtract 4, so subtraction key 4 in y sub 1. 2/3 x minus 4 in y sub 1, and then in y sub 2 we're going to do negative, use the negative key, not the subtraction key. And again, parentheses for the 3/2. And then plus 2, after you get your x in there also. Okay, we're going to do a zoom 6 to start with. Okay, zoom 6, that's our standard window. Zoom 6, just do that one. Tell me, do the lines look perpendicular?
No.
No.
No, they don't. Okay, so did we screw up?
Yes.
Possibly, yeah, possibly. Well, notice something about that window, though. What's true about it? What's true about the window on the graphing calculator? Is it a square?
No, it's a rectangle.
It's a rectangle, so we need to make it a square, don't we? So we're going to do zoom 6. We're going to square this window up. So zoom 6. Do a zoom 6 now. Now, do they look perpendicular? They still don't. Turn your calculator if you have to, you know. Like,
No.
put the corner of your notes in it. Zoom 5. Oh, excuse me, zoom 5. Did I say 6 again? Okay, sorry. Yeah, zoom 5, you guys. Sorry. Zoom 5. God, yeah, zoom 6 is what we just did.
Now it does.
That's the rectangular window. Now does it look perpendicular?
Yeah.
Okay.
If you was up, you're slow.
It's because you use the subtraction key instead of the negative. So you type negative. Okay, now zoom 6. 5. Okay, now do they look perpendicular? We decided. Now that the teachers told you the right one to press. Okay, so when we want to check out when lines are perpendicular on a graphing calculator, we need to square up the window. So keep that in mind, okay? Okay, anybody got questions?
No.
Everybody accomplish it? You should be asking questions if you don't. Okay, I'm gonna let Ms. Olson come over and show you what I'm gonna use. Okay, anybody else? Okay, then those of you who got it to work, I want you to do a second on to turn it off for a moment, and then we will use it to check out some others in a little bit. Okay. Okay, so you don't need to cover them up because we're gonna use them again, but just turn them off so that we can save on the battery life. Okay, so notice something about in number 6, our 4 equations. Are they all in slope-intercept form?
No.
Okay, is that a big deal?
No.
Why
You can
not?
still find the slope in point slope form.
Yeah, we just need the slope, don't we?
Yeah.
We don't care about the y-intercept or perpendicular line. The only thing we care about is the slope. And the first one is in slope-intercept form, so we can get the slope from it. The next 3 are in what form? Point slope form, so we can get the slope from it. So go ahead and identify all those slopes, please. Yeah, you just grab that next time. Okay, how do we determine which ones are perpendicular again? What do the slopes have to be? One has to be negative, the other has to be positive, and then when you ignore the signs, they also, they have to be what relationship do they have to have? Reciprocals. Okay, do we have any opposite reciprocals up there then right now?
Yes.
Which one?
A 1 and 4.
So the -3/7 you're saying, and the 7/3? So 7/3 is the reciprocal of 3/7, and one is negative and the other is positive? Okay, then we're gonna say that y equals -3/7 x subtract 4 is perpendicular to y subtract 7 equals 7/3 times x minus 3.
And 2 and 3.
And when you're doing this in your homework, don't just say which ones are perpendicular without what? Identifying the slope, writing it down. What are those actual slopes, okay? Are there any others?
Yes.
Okay, which ones?
2 and 3.
2 and 3 are. So in other words, you're saying that -7 and 1/7 meet the standard of being reciprocals and opposite signs.
Yeah.
Okay, so we have y minus 4, y subtract 4 equals -7 times x plus 2 is perpendicular to, you're saying it's perpendicular to y minus 1 equals 1/7 times x minus 4. Okay, I want these 3 and Austin and Morgan, I want you guys to check out the first pair that we say up there. So go to your y sub 1 and y sub 2, everybody clear out what's in there. And I want you 6 to check out the other pair for us. Make sure that they are perpendicular. So you got a paper in front of you where you're supposed to write it down. I don't know why you guys are looking up. You don't trust your own writing? Oh, they're not in slope-intercept form. Is that a problem?
Yeah.
Huh. Well, how can we still do it and not have to work very hard? Anybody think they know what we could do with those 3 that are not in slope-intercept form? What could you do? Over here in this one, for you guys over there on that side of the room, could we not just say, you know what? If I add 7, I have y alone? And for you guys over here, they're doing these. Couldn't you say, if I add 4, y would be alone? If I add 1, y would be alone? And then press, probably do a zoom 5, or yeah, zoom 5, just in case it won't do a square graph. I don't know if it remembers it or not, so. Zoom 5 to graph them. If you're struggling getting them in, get your hand up so we can get your help, because you need to know how to use these graphic calculators when you leave me. I'm not going to teach you. Or am I wrong about that, Claire? Did they teach you how to use graphic calculators past algebra?
Kind of assumed I know how to use them.
Yeah, pretty much assumed. Maybe certain things that they'll say like, well, they probably didn't do this. New things. Okay, anybody for the first set of equations, did they prove to be perpendicular? Yeah. Okay. How about the second set? Anybody get it and they look like they're perpendicular?
Yeah.
Yeah? Okay. So again, oh Josh, why aren't you doing this? Okay, first of all. Well, probably covered it because that clock was on, that might be part of it. Okay, so the hard part is sometimes is, especially when they have not a very steep slope, they get pretty close to another line on, because we have the axes on there also. So don't pretend you're doing this, actually do it, okay? Okay, so we had enough verification that we need to move on, so for right now, we can just turn them off and we'll, give you another chance here in a bit. Let's go to the back side. And of course we're going to do just like we did with parallel lines. They're going to give us a line. They're going to ask us to give a line, but not parallel this time, perpendicular to it. You reckon all my graphing calculators? And going to a given point. So let's go, and you know what? Go ahead and turn your calculator on really quick and go to and put in, take out your y sub 1 and y sub 2. Just a little bit easier for those of you that were struggling with those fractions. I want you to put in a given line. Y equals x minus 6. Put that one in. Clear out your y1, y2. Don't have anything else in there except this equation. Okay, just press graph for right now. What do we have to find?
Line is perpendicular.
A line that's going to be perpendicular to that one. What kind of a slope does this one have? Positive or negative? Positive. So that means the slope of our perpendicular line better be what? Negative. It better be going the opposite direction. And what else has to be true again? Anything else? The slopes have to be reciprocals, not only opposite signs, but they also have to be reciprocal. So you know what? We can, and then we have one more restriction for this. What else? How many lines would be perpendicular to this one, do you think? A lot. Yeah, we could draw a whole bunch of lines that would be perpendicular to this one, but we need a line that does what?
Goes through the line.
Goes through ordered pair, yeah, it has to go through that point. Okay, so go ahead and just turn those off for a minute. That equation will stay in there for you until we get our new one, and then we'll see if we have a good equation. Okay, what's the slope of our given line? Positive 1. There's an invisible 1 there in front of that x. Therefore, the slope of the new line has to be what? Negative 1. Good job. Okay. Well, if the slope of the new line has to be negative 1 and it has to go through ordered pair negative 1, 2, we need an equation in slope-intercept form. We're going to get it so that we can check to see if it will be perpendicular or not. So go ahead and do that. You know how. You can either use point-slope form or you can use slope-intercept form. Okay, don't even worry about what I got. Take what you got and put it in the graphing calculator and do a Zoom 5 and see if you were successful or not. You need an equation in slope-intercept form so that you can put it into the graphing calculator. check myself out, you guys check yours out. And one of the most important things with graphic calculators is always to make sure you're using the negative key when you mean negative and subtraction when you mean subtraction. Yes, I did.
I didn't.
You did?
Because my y-intercept is.
Your y-intercept didn't
I
turn out to
didn't
be
go
positive
through
one?
y too, because yeah, and I know.
Okay. But you figured out what you did wrong, so you're fixing it on your notes? Okay, so now, not only can you be, happy that you got it looks perpendicular, but what else has to be true? Since there's an infinite number of lines that could be perpendicular,
That's square root negative 1, 2.
you gotta go to second graph, which takes you to the table, and where x is equal to negative 1 in y sub 2, there better be a 2 for y. And mine there is. So I'm feeling pretty confident I have the right equation for the new line.
Did you get it?
Questions? Okay, then let's move on to number 39. Given line, negative 10x plus 2y equals 8. Ready to grab the slope from that?
No.
What form is that?
Standard.
It's a standard form. Does standard form give us the slope? Heck no, it doesn't give us much of anything, really. Okay, so we're gonna have to put it in. There's only one way to do this. I don't think you're gonna wanna try and put this in point slope form. You're gonna put it in slope intercept form. We're gonna get the y by itself. So what's our first move? Add 10x. What's our next move? Divide every piece by 2. Okay, what do we need from that? Why did I go through all that work?
This is the slope.
You get the slope, okay, so what is the slope?
5.
5, okay. Therefore now, our given line has a slope of 5, and we need a line perpendicular to that one. So it has to go through ordered pair 4, negative 3. What else do we need?
Slope needs to be negative 5.
The slope needs to be negative 5?
Negative 1.
Negative 1/5.
Negative 1, negative 1/5. Okay, let's all make up our mind. Which one should we go with?
Negative 1/5.
Negative 1/5, because the reciprocal of 5 is 1/5, and 5 is positive, so the 1/5 has to be negative. So we need a slope of negative 1/5. Okay. Now we have to find our equation of our new line, right? So I don't know which method you like better, but I don't know, I just tend to do this one all the time, I don't know. So I'm going to get started, and if you're doing it a different way, you can feel free to go ahead and do it your way. And we're not going to use the calculator to take negative 1/5 times 4. What's a negative times a positive? Negative. What's 1/5 4 times? 4/5. 1/5, 1/5, 1/5, 1/5, that's 4/5. So negative 4/5. Now I need to get that 4/5, that negative 4/5 out of there. Oh, this is where the rubber meets the road. Now, how do I add a fraction to a whole integer? Oh, we could rename that negative 3 as 15/5, you're saying? Okay. Negative, but it would also be negative, right? Okay. And then we could add 4/5. And what do we get?
Negative.
Negative what?
11/5.
Negative 11/5.
2 and 1.
So now, if we were going to graph it, it would be nice to know its mixed number name. But since what we're going to do is put it into the graphing calculator to check out the graph, let's just leave it as an improper fraction. Let's say that our equation then is y equals negative 1/5 x minus 11/5. Okay? Go ahead and go to the graphing calculator and check this out. We have the y equals 4 plus 5x, or 5x plus 4. And then we have our y equals negative 1/5 x minus 11/5. We have a negative sign for negative, subtraction for subtraction. Parentheses around fractions. By the way, you can use decimals when they're nice decimals for fractions. It's not going to mess it up, but I just stay in the habit of using fractions because not all fractions are nice decimals. Anybody got it yet? How do we do? Good? It looked like we were successful. Not everybody's quite there yet. So again, you are not going to have to graph in your homework, but we're using the graphing calculators to show us we have to have opposite reciprocal slopes to create perpendicular lines. They have to be going opposite directions. I want you to see it on the graph, and they have to form right angles, don't they? Okay. So questions, anyone? Make sure you're not quitting until you're done here. Make sure your notes are complete. Okay, no questions? Okay, once you have been successful, you have your notes completed and you've been successful with the graphing calculator showing it's in there and you've done a zoom 5 to make sure that you can prove that they are perpendicular, then you may turn off your graphing calculators and return them to the case and get started on your homework. Anybody need my notes up there any longer?